They just basically want to find the intersection of these two equations. And so these two equations, I guess I could read the story. It does matter to have it in context to see how things work out. I've got 1.5 times x plus 22, okay? And to keep things in context, you know, that's good. X is the age in years, y is the length in centimeters. And basically what we're trying to do is compare, basically there's some diagrams, and they show the birth lengths and growth rates of two species of sharks. If the growth rates stay the same, at what age would the spiny dogfish and the Greenland shark be the same length? So here you have two growth models, and I don't know what the answer is, but you have one shark that kind of grows at a certain length, and then maybe another shark that grows at a slower length, and they want to know when they're going to be the same length. Okay, does that make sense?
Yeah.
And so now we could do exactly like example number 1, and they've already given us those equations, so I'm just going to move this over to the side here, and I'm going to clear this out. In fact, they even wrote in the subset notation that our calculators use, right? So we're going to say y sub 1 is equal to 0.75, all right, times x plus 37, and then 1.5 x plus 22. Now before I do this, I want to point a couple things out. Remember guys that this term here and this term here, that is the slope, right? Those are both slopes, and those are also what we call the rate of change, right? So in this case, it's the rate at which the fish grows. Which one grows faster? The first or the second one?
Second.
Yes, the second one, because it has a greater value for the slope. Now, the second one is the y-intercept, right? So this is the y-intercept, and the y-intercept occurs when x equals 0. Okay? Now, if we're measuring in time, and time equals 0, what is this really? Well, these are usually what we call an initial, oops, that didn't fit in there right, condition. So we would call that an initial condition. Does that make sense?
So that'd be like when it's born.
Yeah, so when it's born. So that's what they were saying in the story problem, right? Mm-hmm. That some fish are born at one size. So that's the average birth length, okay? And this is all done in centimeters. All right, so now let's get to the solution, which is really easy. I'm just going to graph these two. I'm going to change the windows. We don't know when the two are going to intercept, but what do you think the minimum and maximum y values should start off with? Yeah, like between 22 and 37, right? Because those are the y, right? Do we have any negative x values? No. So we're going to start at 0 for x, and I don't know, I'm going to plug in 50. I don't know how big it'll be. I can always go back and change it, but we know the y value should be a minimum of 20. I'm going to put 100 just in case, because I don't know. It might not be that much. Okay, I fit it on the graph. Now I'm just going to find the intersection of these two lines. Hit second, calc, go down to option 5 for intersect. Use my cursor to get that pretty close. And I'm going to hit enter, 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 20 and 52. Now what this is saying is the intersection here is at 20, 52. What does that mean? Remember that x was the number of years the fish was alive, and that y was the measurement in centimeters. So if they intersect at 2052, what does that tell you? Yes?
After 20 years, they'll be 52 centimeters.
Yeah, after 52 years, their average length will be 52 centimeters. Does that make sense?
After 20.
What did I say? 52? Did I say it backwards? You guys know what I meant, right?
No.
So.
Good Lord, you could figure it out on your own. Well, I wrote it down right? So after 20 years, one fish will be 52 centimeters long, on average. Well, actually, both fish, right?
Yeah.
And which is interesting because
That's how old
This
it
one
is.
starts off at 37, grows at a slower rate, and after 20 years it'll be 52 centimeters. And then this one is actually bigger when it starts, but it grows at a faster rate. And so they match up here. One last way to verify that, hit second graph, and we can look at the table, and we can scroll down till x equals 20. And you can see how they're starting to catch up to each other already at 12. See how this is like 48 and that's 44. But at 20, they'll both equal 52. See how that is?
Yep.
Okay. Any questions?
Mm-mm.